Now, our contract is good as it is. It allows us to store a single favorite number. But what if we want to store a range of favorite numbers? Or maybe we want to store a whole bunch of different people who have different favorite numbers. Well, how do we do that? There are several different ways that we could approach this. One of the ways we could start approaching this is by creating what's called a struct of people, or we could create a new type in our Solidity. We can create a people object that holds both someone's name and their favorite number. To do that, we say struct people, uint256 favorite number, and a string name. Now we've created a new type called people, kind of like uint256 or Boolean or string. Now we have a people type that we can use. Now, similar to how we created a uint256 public favorite number, we could do the exact same thing, but with a people. We could say people public, we can call this person, and we can create a new people and assign it to this variable person. So we'll say equals people public person equals, and we'll add parentheses here to signify we're creating a new person. And since we made this a struct, we add little curly brackets here to let Solidity know that we're going to be grabbing from these struct variables. We'll say favorite number is going to be 2, and then name is going to be Patrick, semicolon. And then we can hit Control S, or we can go ahead and compile. Now, if we go ahead and deploy this, we now have a new person. Since this, again, is a public variable, it has a getter function called person. And if we click person, we see our new object. The favorite number is 2, and then the name is Patrick. You see this 0 and this 1 because these are showing the index of the different variables. For those of you new to computer science, typically in computer science, lists start with the number 0. So at our 0th index, we have a uint256 called favorite number, which is saved at 2. And then at index 1, we have a string, which stands for the name of Patrick. Whenever you have a list of variables inside of an object in Solidity, they get automatically indexed. So favorite number gets indexed to 0, and name gets indexed to 1. Interestingly enough, if you have a whole bunch of variables inside your contract, like we have public favorite number, this favorite number actually technically is getting indexed at the 0th storage slot. And if we were to make another one of these, maybe uint256 public brother's favorite number, this would technically be indexed at the 1st slot. And then if we were to make one more, maybe sister's favorite number, this would be indexed at the 2nd slot. So favorite number at 0, this at 1, and this at 2. But we'll learn more about that much later in the course. Similarly, favorite number is indexed at 0, name is indexed at 1. Now what we have is great, but if we want a whole lot of people, are we gonna have to keep copy pasting and changing the people's name? Person 2, their favorite number will be 3. We'll name them Allie. Person 3, their favorite number will be 7. Their name will be Chad or something. Oops. This obviously isn't a great way to create lists and large number of peoples because we have to statically keep typing them in. So a much better way to create a list, and let's actually just go ahead and delete Patrick too. A much better way to create a list is to use a data structure called an array. An array is a way to store a list or a sequence of objects. Creating an array works the exact same we've seen to initialize other different types. Typically, we do the type of the object, the visibility of the object, and then the variable name. We do the exact same thing with arrays. We'll say we want a people array. These little brackets represent that we want an array of people. We'll give it a visibility of public, and we'll call it people. You could do the same thing with uint256, for example. You could say uint256 public favorite numbers list and just add this little array key here. And now favorite numbers list is going to be an array or a list. We're going to comment that out for now. Now, if I were to go ahead and deploy this contract, let's go ahead and delete the last one. Let's redeploy. We now have this blue people button here. Remember, since it's public and it's a variable, it automatically is given a view function. It's given one of these blue buttons. And instead of just having it be a single button where the value shows up, it's giving us a form to fill out. It wants to take a uint256 as an input parameter. So if I put 0, I get nothing back. If If I put 1, I get nothing back. No matter what you put in this box right now, we're going to get nothing back. This is because our people array or our people list is currently empty. And the value that it wants is going to be the index of the object that you want. So for example, if at index 0, I had Patrick, it would show Patrick for 0. If at index 1, I had John, or actually better yet, 2 Patrick, 7 John, etc. This is what it would show. But since it's empty, it's going to show nothing. And let's go ahead and remove the public variable from favorite number so that we don't get the duplicate functions at the moment. We'll just get the retrieve function. We'll show you how to add to this array in just a second. This type of array is what's known as a dynamic array because the size of the array isn't given at the array initialization. If we were to say a people array and add a 3 in these brackets here, that means that this list or this array of people could only be 3 people big. If we don't give it a size, it means it can be any size, and the size of the array can grow and shrink as we add and subtract people. If I add 3, it can only have a maximum of 3 in the array ever. We're going to work with a dynamic array because we're going to want to add an arbitrary number of people to this array. So let's go ahead and create a function that's going to add people to our people array. So we're going to say function add person, and we're going to take string memory name as input parameter, and I'll explain that in a minute, and a uint256 underscore favorite number. We're going to make this a public function. What we're going to do is we're going to call a push function that's available on our people object. So we're going to say people.push, and we're going to create a new person, a new people object, which is going to take in the favorite number and the name. Now, this might be a little bit tricky to you, so let's break this down. People here is capitalized. So we know that since it's capitalized, it's referring to this struct people and not our variable people. The lowercase people here is referring to this lowercase array. So we're saying our array.push, or push is the equivalent of adding basically, a new people that grabs favorite number and name. Another way that we could actually do this is we could create a variable of type people and then add it like so. So we could say people, new person equals people, and then we could put those brackets the same way we did before. We say favorite number is going to be this input value, this parameter, and we could say name is going to be this parameter. Now, if you hit save, you'll get this error set here saying data location must be storage, memory, or call data for variable, but no one's given. For now, we're just going to add the memory keyword here, and I'll explain what it does in a little bit. And then, of course, we need to add the new person into our people.push right here. So this is how we're actually going to push people into our people array. And I'll get to this memory keyword in a bit. Now, if we go back to our deploy tab, we delete our last contract. Let's deploy this new one. Right now, if we try to look at the 0th person in our people array, we get nothing. But let's go ahead and add a person. We'll call it Patrick will be the name, and 7 will be the favorite number. So we added Patrick, we added 7. Now if we look at people 0, we should see the 0th person has a name of Patrick and a favorite number of 7. Boom, and that's exactly what we do see. We see a favorite number of 7, and we see a string name Patrick. We tried to add John and do a 16, and we hit add person. We can see our transaction go through. And now if we go to people at 0, it's still Patrick with a favorite number of 7. But if we look at the people at index 1, it's going to be John with a favorite number of 16. And if we look at 2, this of course should be blank. And we do indeed see nothing actually happens here. Perfect. Now there's actually a couple of different ways to create this new person here. Like we showed before, we can use this bracket notation, or what we can do is we can actually just add the parameters in the order that they show. So the first parameter for people is going to be favorite number. So we can just do favorite number, comma, and the second one is going to be name. And the second one is going to be name. So if we save this line we just created is the exact same as the last line. We're being a little bit less explicit here. So the other way is generally a little bit better because it's more explicit as to what variables are what. Or we don't even need to save to this variable here. We could take out this whole line, replace new person with exactly what we just saw, like so. Now we don't even need the memory keyword.